Cyclotron. The cyclotron is a machine used for accelerating charged particles, such as protons or ions, to higher energies. Principle and working of cyclotron. Cyclotron works on the principle that a magnetic field can restrict a charged particle to move in a circular path with a frequency which is independent of its speed, whereas an electric field can accelerate it. The cyclotron consists of an evacuated chamber in which there are two Ds insulated from each other. The Ds are open along their straight edges. The chamber is placed between the poles of a very strong electromagnet. An electric oscillator establishes a high-frequency alternating voltage across the gap between the Ds. The source produces the ions to be accelerated. Suppose an ion with a positive charge Q and mass m is at the center of gap when D1 is at negative potential with respect to D2. The ion is accelerated across the gap by the electric field between the Ds towards D1. Inside a D, the magnetic field causes the ion to bend its path into a semicircle of radius r inside a D. Here, charge follow the given relation. QVB is equal to mv squared divided by r. The cyclotron frequency at which the ions circulate in the field is given by QB divided by 2 pi m. And time taken by the ion to complete a semicircle in a D is given by pi m divided by QB. At resonance condition, the ion arrives between the Ds exactly in time to be repeatedly accelerated and gains energy. This energy gain does not affect the resonance condition except increasing the orbit size. The ion describes a spiral path, gaining energy each time it passes the gap, but remaining in phase with the alternating voltage. The ion acquires the required energy to have a radius approximately that of the Ds. It is then deflected by a negatively charged plate and leaves the system. The maximum energy attained by the ion is given by product of B square, R square and Q square divided by 2m. Applications and limitations of cyclotron. It is used in the study of nuclear reactions. It is used to implant ions into solids and modify their properties. It is used to produce radioactive substances which can be used in diagnosis and treatment of ailments. At high speeds, the cyclotron frequency decreases due to realistic mass increase, causing the particles to get out of resonance with the electric oscillator. It can be used for accelerating electrically neutral particles such as neutrons.